We live in a universe that is brimming with brilliant things. On a dark night, for example, a person can look up into the sky and see hundreds of sparkling stars without the use of any specialized equipment. Nonetheless, these stars only make up a minute fraction of the Milky Way galaxy. But what came before the stars, and how could trillions of these dramatic objects appear all around the cosmos according to the Big Bang Theory? Hello and welcome to Z. Don't forget to subscribe and click the bell icon. What did the early universe look like? The darkness that is beyond the cosmos is illuminated by the light of the billions of stars that are contained within the galaxies that lie beyond it. 13.8 billion years ago was the beginning of time and space as we know it today. The fundamental building blocks for everything that exists in the world now came into existence at some point in time. The researchers have pieced together a general timeline of the significant events that took place after this amazing point in time. Researchers have been able to piece together a rough timeline of the major events that occurred after this incredible moment, despite the fact that no one knows what occurred before this moment, which is the point from which our understanding of the universe breaks down. Despite this, researchers have been able to piece together a timeline of the major events that occurred after this incredible moment. The Big Bang, in contrast to what its name suggests, was not an explosion in space, but rather a time when the universe was extremely hot and dense and space began to rapidly expand in all directions everywhere at once faster than the speed of light. Shortly after the universe would have appeared opaque, and it would have been like a hot, dense soup of particles including protons, neutrons, and electrons. The expansion of space occurred shortly after the universe would have appeared to be opaque, and it would have been like a hot, dense soup of when the cosmos was in this state. It would have been comparable to a scalding, dense stew of particles that included protons, neutrons, and electrons. As the temperature of the universe dropped, subatomic particles known as nuclei were formed as protons and neutrons began to clump together. Under these severe circumstances, matter would have been dispersed over the universe like a dense fog, which would have scattered all of the light that was already present. After around 380,000 years, as the cosmos continued to cool, nuclei eventually attracted electrons, transforming them into neutral atoms and making it possible for light to flow freely for the first time. This occurred as the universe continued to expand. The breakdown of parity was the initial step in the process that made it possible for light to move without restriction. Before the universe started becoming more transparent, there was a time when light could not freely travel through the early opaque universe. This changed when the universe started becoming more transparent. This was as a result of the fact that light frequently impacted free electrons in the early universe while it was still relatively young. After all of the free electrons had been connected to their respective proton nuclei in order to form neutral atoms, light was able to travel unimpeded through space and along straight lines because there were no longer any obstacles in its way. Because of this, the initial bright flash of light that was created by the Big Bang is now dispersed throughout the cosmos. This flash of light is what we know of today as the cosmic microwave background, which depicts the earliest image of the world that is conceivably imaginable. Citation needed. This is an illustration of the cosmic microwave background, which represents the universe roughly 380,000 years after the Big Bang. Even the first stars to form within the first protogalaxies didn't begin their lives for hundreds of millions of years after the formation of those objects. This indicates that the stars, galaxies, planets, and other objects that we see today when we look out into the cosmos did not just materialize out of nowhere after the Big Bang. Rather, they were created in the aftermath of the event known as the Great Bang. Instead, their formation required tens or even hundreds of millions of years to complete. Nevertheless, there was once a moment in the history of the universe when there were no stars and it was completely dark everywhere. This period is known as the Dark Ages. The term cosmic dark ages refers to the period of time that occurred after the universe became transparent, but a very long time before the development of the first stars. This period of time occurred after the cosmos became transparent, but a very long time before the formation of the first stars. There was a time span of several 100 million years during which nothing in the cosmos emitted any form of visible light. In spite of this, the universe did not lack any form of substance. The matter that was formed as a result of the Big Bang started to clump together, which caused it to attract even more material due to the gravitational force. After a period of time, a massive structure that is now referred to as the cosmic web started to weave its way through the void that is the cosmos. It is conceivable that intertwining filaments of dark matter contributed, at least in part, to the production of these enormous strands of gas. Even though it cannot be seen, the mysterious substance known as dark matter can be found embedded inside the gaseous filaments. Were the first stars, the progenitors of our sun, ignited into existence as the thick clouds of gas in these areas became denser and it began to collapse. And where, in the densest regions, the gas became so hot that nuclear fusion reactions began. And where, out of the darkness, the dawn of starlight emerged, and the universe was finally illuminated. It is likely that the first stars to ignite in the cosmos were enormous objects consisting almost completely of hydrogen and helium. This theory has been supported by a number of observations. These are the constituents of the universe that were brought into existence as a direct consequence of the Big Bang. They would not have contained any of the heavier elements, such as carbon, nitrogen, oxygen, or iron, which are all found in stars that are still glowing brightly today. They burnt with such ferocity that they glowed a dazzling blue with the energy of more than 1 million suns, and they were probably hundreds of times more massive than the sun. It is anticipated that stars with a mass that is 60 times that of the sun will have a lifespan of less than 1 million years. This prediction is based on current scientific understanding. This is most likely due to the fact that Titan-like stars presumably had extremely enormous diameters in their heyday. This may imply that the first stars, also known as population 3 stars, ran out of fuel a very long time ago and burst in a spectacular cosmic event known as a supernova. This would be the case because population 3 stars are thought to have been the first stars. Due to the fact that these stars no longer have any fuel left to burn, they can only be viewed as remnants such as neutron stars or black holes at this point in time. Despite this, when they were destroyed by supernova explosions, the population 2 of stars that followed in their footsteps would have had their first source of metals to work with. These only have minute levels of a variety of different elements. Astronomers refer to any substance that is heavier than either hydrogen or helium as a metal, and this definition can be applied to any substance. After that, these stars of population 2 went on to become the parents of the metal-rich stars of population 1, which we can observe today. Since the very first stars arose, there have been trillions of them, yet ours is likely the most amazing and extraordinary of all of them, since it is likely the most unique of all of them. Why? Because the planet, which, to the best of our knowledge, is the only place in the universe in which life can continue to exist, receives its food from the sun, which is our home star. And in our particular case, intelligent life that is able to explore the cosmos in order to discover what might have occurred in the earliest moments of the universe, the ones that eventually led to our own existence. This is important because it will allow us to understand how we came to be. Because, at the end of the day, every single human being that has ever lived started from the dust of these ancient stars. This is the incredible cosmic bond that we all have. Leave a comment below telling me what you think these ancient giants of the universe were and what your thoughts are on the subject to let me know what you think about it. This is all for now. Thank you for being with us.